भाग्यश्री मठ, भाग्यश्री मठ, भक्ति, भक्ति, भारती, भारती, चेतन कुमार, चेतन कुमार, दीपक, दीपक, दिव्या, दिव्या, गणपत में शिवाजी,
Present, sir.
ओके, ज्योति, ज्योति, किरण लिगाड़े, किरण लिगाड़े, लक्ष्मीकांत, लक्ष्मीकांत, मानतेश,
Yes, sir.
ओके, मोले प्रेम,
Present, sir.
राइट, नागेश,
Yes, sir.
ओके, नंदीश, नंदीश, पूजा पाटिल,
Present, sir.
राइट, प्रमोद कुमार, प्रमोद कुमार, प्रवीण मखदूम, प्रवीण मखदूम, प्रियंका, प्रियंका, संध्या, संध्या, संतोष पुजारी, संतोष पुजारी, संतोष सोनार, संतोष सोनार, शहबाज, शहबाज,
Present, sir.
ओके,
Present, sir.
शफिया, राइट, शफिया,
Present, sir.
राइट, श्रीधर, श्रीधर, सृष्टि, सृष्टि,
Present, sir.
ओके, सिद्धार्थ वर्णेकर, सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सिद्धार्थ पाटिल, सुप्रिया,
Present, sir.
ओके, वंदना,
Present, sir.
राइट, वसंत दुडमनी, वसंत दुडमनी, वेददत्ता, वेददत्ता, योगेश, योगेश, महेश दुडमनी,
Yes, sir.
ओके, बालेश मुडलगी, बालेश, तैक मोहम्मद,
Yes, sir.
राइट, प्रवीण राठौड़, प्रवीण राठौड़, अभिषेक पालेकर,
Yes, sir.
अभिषेक पालेकर, ओके,
Yes, sir.
राइट, ऐश्वर्या, ऐश्वर्या, अमानुल्ला, अमानुल्ला, पंडुरकर तनय मोहनदास, पंडुरकर तनय मोहनदास, भावराव, भावराव, शोधन, शोधन, राइट, द्यावण्णवर अनिल कुमार शेकप्पा,
Present, sir.
ओके, नंद कुमार, नंद कुमार, प्रमोद केस्ती, प्रमोद, रोहिणी पावळे, रोहिणी, रोहित अलवाणी, रोहित अलवाणी, शशिधर गौडर, शशिधर गौडर, श्रीधर बड़गेर,
Present, sir.
राइट, स्नेहल सावंत, स्नेहल सावंत, वैष्णवी,
Present, sir.
ओके, साइश,
Present, sir.
राइट, कार्तिक यम, कार्तिक यम, स्मिता यम, स्मिता, ओके,
Sir, roll number 9.
Sir, Babu Mori.
1 minute, just a minute. Sridhar Solkarnavar is 32, okay. Tell me, anybody joined?
Sir, Babu
Sir,
Sir.
roll number 16.
Bhagyashree Mat I have marked. Then Bhaurao More I have marked. Who else?
Roll number 2.
Roll number
16.
2.
16. Jyoti.
Yes, sir.
Okay. Anybody else?
Sir, roll number 2.
I have marked. Abhinandan I have marked. Anybody else?
Sir, 32.
32. Sridhar I have marked. Anybody else?
Yes, sir.
Okay. In the last class, we were discussing the programs, right? In continuation with that, are you able to see the screen here? Screen is visible?
Yes, sir.
Yes, sir.
Okay, right. Okay, the program homework that I had given, it is the same program. That is, assume that P1 is an input port connected to a temperature sensor. Write a program to read the temperature and test it for the value 75. According to our test results, place the temperature value into the registers indicated by the following. That means they have asked to assume P1 as input port. If it has to be configured as input port, first we have to store FF in that port P1, right? And then whatever value it reads, that we can copy it into A register. We can copy it into A register, the value read by the port P1. It is connected to a temperature sensor. P1 port is connected to temperature sensor. P1 port of microcontroller is connected to a temperature sensor. What is a sensor? It senses the temperature. It measures the temperature value. Write a program to read the temperature and test it for the value 75. We have to check whether the temperature value is 75 or not. That means again we have to compare the temperature value with 75. Whatever value is read by the temperature sensor, that value we have to compare with the value 75. According to the test results, according to the comparison, place the temperature value into the registers indicated by the following. If the temperature value is 75, then we have to store after comparison with value 75. If it matches, that is if it is 75, then we have to store the value 75 temperature value in A register. If the value is less than 75, if the temperature value is less than 75, whatever is the lesser temperature, that we have to store in a register R1, that we have to store in register R1 here, right? If the temperature value is greater than 75, if it is more than 75, then that increased temperature value or more temperature value, that we have to store in register R2. Okay, this is how we have to write a program for this. Now let us see how to. Have you all tried this program? Anybody? Anybody, have you all tried this program? Yes. Have you tried out this program? Anybody? Shafia, have you tried out? Shafia?
Sir, yes, sir.
You have tried? Okay. What are the instructions you are using? How you are reading the port? Shafia? How you are reading the port?
Sir,
Which
it
is your
may wrong.
No, not, don't worry if it is wrong. At least you have tried. That is a big thing. Okay. How you are reading the port? Which instruction you are using to read the port? First, you have to store FF in the port P1. Is it not? Move
Yes,
P1
sir.
comma hash 0 FFH. Once you have stored FF in port P1, now you can read whatever value is stored on port P1. Right? Whatever value is the temperature of the sensor that you can read from port P1, and then you can copy it into register A, accumulator register. Next instruction would be move A comma P1. Next instruction will be move A comma P1. Now after reading, copying the value into A register, after copying the value read by port P1 into A register, we have to compare with the value 75. We have to compare this value, red value, with the value 75. Which instruction we are supposed to use for comparison?
CJNE.
CJNE. Have you used that instruction?
Yes,
Which
sir.
instruction you have used for comparison? How
CJNE,
you have
sir.
compared? Yes, Shafia? How you are comparing? CJNE A comma hash 75 comma next, or any other target address you can mention there. CJNE A comma hash 75 comma over or next, whatever it is. Right? Then next, once if it is not equal, then you have to check for the whether it is greater or lesser. How to check whether it is greater or lesser? How will you check? Shabaz? How will you check the value is greater or lesser? Shabaz. Mantesh? Mantesh?
Sir, don't know, sir.
No, how you are going to check whether the value is greater or lesser? See, there is a value you are comparing. Okay. So whenever you are comparing, which flag will be set or which flag will be reset based on whether it is a greater or smaller value. Suppose say the value is 80. I'm comparing 80 with 75. 80 is greater than 75. Then whether the carry will be 0 or 1.
1, sir.
It will be 0. If it is greater, it will be 0. If the value is smaller, if the value is smaller than 75, then it will be 1. Carry flag will be 1. Clear here. Okay. If the value is greater than 75, then the carry will be 0. It will be reset. If the value is less than 75, then the carry will be 1. Okay. It will be set.
Sir,
Clear
then
here.
overflow
Huh?
flag will not come, sir.
Which one?
Overflow flag, sir.
Overflow flag not necessary here. Just if we check the carry flag, that would be sufficient.
Yes, sir.
Right? It will be sufficient if we just check the carry flag. When the overflow flag will come, if it is exceeding the limit, right? Suppose the limit is FFH. If it is 8-bit register, right? If it is exceeding that limit, if it is more than FFH, then what will happen? If it is more than FFH, there is an overflow condition, just as if the tank is overflowing. Correct? So because of that overflow condition, what happens? So overflow flag will be set. OV flag will be equal to 1. But here there is no necessity because the values, whatever we are checking, we are assuming that they are less than FF. The temperature values are less than FF. With that assumption and with the reference value as 75, we are comparing. Got the point here?
Yes, sir.
Following here? Okay. So let us write the program for that. A small program. First, we have to configure the port P1. For configuration, move P1, comma, hash 0 FFH. Move P1, comma, hash 0 FFH. Then, once it is stored with the value FF, okay, then I will move the value, whatever is read by the port P1, that into A register. Move A, comma, P1. Move A, comma, P1. Read P1 port, that is the temperature value. This is make port P1 input port, make P1 input port, make P1 input port. Second instruction is for read P1 port, read P1 port, that is the temperature. That is the temperature. Clear here? Next, we have to use the compare instruction. That is CJNE. I have to compare now value in A with the value 75. If they are not equal, jump to over or next target address. That is jump if A is not equal to 75. Jump A is not equal to is not equal to is not equal to 75. Next, suppose the value in A is 75 and it equals to 75. Then what will happen? See what they have mentioned in the statement. If the value equals 75, if T1 is equal to 75, then A is equal to 75. You have to store 75 in A register. Is there 75 in A register? Yes. Already in A register, whatever is the read value of temperature from sensor, that is 75, it is equal to 75. The value in A register remains 75. We did not change it again. The value in A is 75 only. If the value in A matches with the value 75. Suppose if the two values are not equal, then it will jump to over. Okay. Here what I am doing, if it is equal, then it will come to next instruction. If it is not equal, condition is true. Okay. If it is equal, condition is false, it will come to next instruction. Next instruction what I will give is SJMP exit. Next. Now, see, compare value in A with 75. If they are not equal, then jump to over. They are not equal, jump to over. Okay. Now, here it will come. Now, here we have to check for the carry flag. Here we have to check for the carry flag. I am using either JC you can use or JNC. Any one of these you can use. JNC to next. That means if the carry is 0, no carry means carry is 0. If carry equal to 0, if carry equal to 0, it will jump to next. If carry equal to 0, when the carry will be 0? Carry will be 0 if the value in A is greater than 75. The value in A is greater than 75, then the carry will be 0. If it is 0, carry is 0. If it is value in A is greater than 75, it will jump to next. So next is somewhere else. I'll write next here. Okay, I'll give it here. Next. So what we should do if the value is greater than 75? See the statement. If T1 temperature is greater than 75, store temperature value in register R2. Store temperature value in register R2. That is a move. Where is the temperature value now? It is in A register. Okay, from A register we have to store it in R2. Move R2, comma A. Move R2, comma A. Then next is exit. Last instruction, exit. There is STMP dollar and then end. Now, if the carry is 0, if the carry is 0, that is if it is A is greater than 75, it will jump to next. Suppose if the carry is equal to 1. Suppose if the carry is equal to 1. Carry equal to 1, that means here no carry means condition is true, it will jump to next. If carry equal to 1, condition is false, it will execute the next instruction. When the carry will be equal to 1, the carry will be equal to 1 if A value is less than 75. That is the temperature value. If it is less than 75, then the carry will be equal to 1. If carry equal to 1, then what is the statement given? If T1 is less than 75, store the temperature value in register R1. If T1 is less than 75, store the temperature value in register R1. So store the temperature value, move R1, comma A. Temperature value is there in A, store it in register R1. Store it in register R1. Right? This is the program move R1 comma A. Then after this instruction, where it should jump, it should not go to move R2 comma A. Directly it should go to exit. I will give SJMP exit, SJMP exit. Right? So like this program will execute. It will check whether the temperature sensed by the temperature sensor, it is equal to 75 or greater than 75 or less than 75. Accordingly, store the temperature values in register A or R1 or R2. Clear here? Is this program clear to everyone?
Yes, sir.
Is this program clear here? Okay, fine. Let us move ahead.
Sir,
Yes,
sir, what that JNC means?
jump
That
if no
instruction.
carry. That means if carry flag equal to 0, when the carry flag will be 0, if the value in A register, if it is greater than 75, what actually it will do is, it will perform the subtraction here. The actual execution of CJNE instruction is, it will perform the subtraction of the value in A with the value given. That is, here suppose say temperature is 80 degrees Celsius, value in A is 80 minus 75 is plus 5. Plus 5 means carry will be 0. It is positive number, carry will be 0, right? Suppose if the value is say 70 degrees Celsius, value in A is 70, then what will be the subtraction? 70 minus 75, it is minus 5. Minus 5, carry will be 1. Carry will be 1. When the carry will be 0, the value in A is more than 75, more than the given value, to perform the subtraction. If it is positive, if the answer is positive, carry will be 0. If after performing the subtraction, if the value is negative, carry will be 1. Depending on this, jump if no carry. Jump if no carry. If carry equal to 0, no carry means if carry equal to 0. Jump if carry, JC, jump if carry means if carry equal to 1. Clear here? So jump if no carry means if carry equal to 0, that means if A is greater than 75, value in A register is more than 75, then it will jump to next. What we have written in next? In next we have written that move the temperature value, greater value in register R2. Suppose if this condition is false, that is if carry is not equal to 0, that means if carry equal to 1, if this carry equal to 1, then what it has to do? The value is smaller than 75. Therefore, store that smaller value in register R1. So this R1 is meant for storing the smaller value. R1 is for storing smaller value, and this R2 is meant for, according to the given statement, what they have mentioned in the program statement, R2 will store the larger value. R2 will store the larger value. Here. Now it is understood here?
Yes, sir.
Okay. Any other questions?
No, sir.
So we can't use JC
We can make use
instruction.
of. Suppose if we make JC instruction, right? See here what changes will occur here if we are using JC instruction. Now, if I use JC, here over is there, over. Then if it is JC to next. JC to next I will mention. Jump if carry. When the carry will be 1, carry will be 1 if the value is smaller. Correct? The value is smaller, then the carry will be 1. So what I will do is in the next here loop, forward loop, I will move R1 comma A. R1 comma A. That is smaller value I have to store in register R1. That is how they have mentioned in the statement. Therefore, the smaller value I will move in register R1. Suppose if this condition fails, that is if carry equal to 1, then it will jump to next. Smaller value is stored in R1. Suppose if it is equal to 0, when it will be equal to 0, if it is a larger value. If it is more than 75, then what we have to do? Move R2 comma A. R2 comma A. Only these statements will change, remaining statements will remain the same. Got the point here? Is it clear here?
Yes, sir.
Any other questions? Any other questions? So you can make use of either JC or JNC, any one, whichever you wish. can make use of that and write accordingly the other statements. Okay, is it clear here? Any other doubts? Understood this program? Shall we go to the next one?
Yes, sir.
Okay. Next program, write a program to get hex data in the range of 00 to FFH from port 1 and convert it to decimal. Write a program to get hex data, hexadecimal data we have to input, right? And this hexadecimal data should be in the range between 00 to FFH. From where we are inputting this hexadecimal data? From the port P1, from port 1, and this obtained data, this inputted data, we have to convert it into decimal. That means you have to convert the hexadecimal number to decimal number. After converting hexadecimal to decimal, save the lower digit of the decimal in R7, that is a low significant digit, then R6, the in between digit, and the most significant digit in R5, that is least significant digit is stored in R7. Then part B is analyze the program assuming that P1 has a value of FDH for the data. Analyze the program assuming that P1 has the value of FDH. They have directly given the value, hexadecimal value. For that value of hexadecimal, we have to analyze the program, right? Now, what is the main program here? What you understood from this program statement? Can anybody tell me? What you all understood from this program statement? What you understood from this question? Write a program to get hex data in the range of 00 to FFH from port 1 and convert it to decimal. What you understood from this?
We convert hex data into decimal.
Very good. You have to convert hexadecimal to decimal. Conversion from hexadecimal to decimal number. That is the main part of the program here. Okay, that is the main logic that we have to find out here. Based on that logic, here and there we have to adjust it, and accordingly we have to write the complete program. Okay. Now here, let us convert it into hexadecimal. So as our normal method of using the port, we have to configure the port if we are using the port as input port. Therefore, I will use the instruction move. Accordingly, what we have written here, move P1 comma hash 0 FFH. So we can use the same statement here, move P1 comma hash 0 FFH. Then what I will do, I will move the value, okay, that is from port P1 into A, move A comma P1, move A comma P1, read the value from port P1 and copy it into A register. After copying the value, whatever is the value read by port P1 into A register, let us assume some value. Here it is configuring the port. Then let us assume A equal to P1. The value, hexadecimal value, let us say it is FFH. Hexadecimal value it is. It is not this FF. Okay. This FF is for configuring the port. To make the port input port, we are storing FF. This value is the value actually read by the port. Okay, we'll take one more value, then it will be clear to you. First, we'll take this FF. The FF in decimal is how much? FF in hexadecimal is equivalent to how much in decimal? 255. FFH is 255 in decimal. FF hexadecimal is equivalent to 255 in decimal. That means if in hexadecimal, if it is FF, in decimal it is equal to 255, right? So this FFH we have to convert it into 255. We have to convert it into 255, a decimal number. Now how to convert it? The logic is we have to divide the given hexadecimal number continuously by A repeatedly by A or by 10 until the final until the quotient is less than 10. Until the final quotient is less than 10, we have to repeatedly divide the given hexadecimal number by 10 or by 0A. Okay. Now for that, what we are doing, now value has already come in A register. Next, let us take the value to divide. So move B comma. If we are dividing, we have to use div instruction. It means one value should be in A register, another value should be in B register. Yes or no? If we are using division operation, we have to use div instruction, div AB. One value, the numerator should be in A register and the denominator should be in B register. Move B comma, what is our denominator here? Move B comma hash 10 or is nothing but A. Is nothing but A. 10 is nothing but hexadecimal 0A. Right? B is equal to 10 or it is equal to 0A. Once I have loaded, initialized, I have loaded with the values, then I will use div instruction. Div AB. Div AB. Now what it will do here? It will perform 255, that is FF divided by 10, that is 255 by 10 or FF divided by A. Take your calci, keep your calci in hexadecimal mode and then divide FFH by 0AH. Take your calci, keep it in hexadecimal mode, divide FF by 0A. First, keep your calci in hexadecimal mode, hex mode. Type FF, then divide 0A. See what is the answer that you get. How much you are getting? FF divided by 0A. Yes, anybody got the answer? Division of FF by 0A is how much? Quotient is how much? Quotient. Is it 19? Anybody
Yes,
getting
sir.
19? Huh?
Yes,
Okay,
sir.
fine. Now what you will do is FF minus 19 into A, because quotient is 19, right? Quotient is 19 and your divisor is 0A. So FF minus quotient into divisor. FF minus FF minus 0A 0A, that is your divisor, into the quotient, that is quotient how much you're getting? 19 into 19. Tell me how much you're getting. It should be in hexadecimal mode only. Don't change the mode of your calci. Keep it in hex mode itself. Find out FF minus 0A into 19. How much you're getting?
17 ED.
No, just check. You will get 2. Just check, please. Remainder. What is the quotient you are getting? 19 you are getting, that is correct. FF divided by 0A. FF divided by 0A is how much? Are you getting? $19 you will get.
Sir,
Just
5.
check.
Yes, sir.
Keep it in hex mode. Keep it in hex mode, right? FF divided by how much? 0A. 0A. Answer is 19. Check it.
Yes, sir.
Then what we all have to do? FF minus 0A into 19. FF minus 0A into 19. This operation you have to perform. FF minus 0A into 19.
5, sir.
5. Very good. 5. Correct. So remainder is 5. It is a remainder. Okay. If you subtract divisor into quotient from the dividend, you will get the remainder. Okay. Remember this. You subtract divisor multiplied by quotient from the dividend, you will get the remainder. So remainder is 0, 5. So after performing the division operation, quotient is always stored in A register, remainder is always stored in B register. Quotient we have got it as A, that is quotient will be in A, that is 19. 19 is the quotient. Remainder is 5. Remainder is stored in B register. It is 0, 5. What I will do, as per the statement that they have mentioned in the program, what they have mentioned, store the least significant digit in R7. Store the least significant digit in R7. This is our least significant digit, 5. It is the remainder. This we have to store it in R7. Move R7, comma B. It will be there in B. Remainder will be there in B. Okay. I will tell you the logic. I will come to the logic. So remainder I have B value I have stored in R7 register. R7 is equal to B, that is equal to 0, 5. That is equal to 0, 5. Once I have stored the value in R7, then again load the value 10 or 0A in B register. Move B comma hash 10. And again perform the division. div AB, div AB. What is the previous quotient in A? That recent value you have to take. Quotient. Quotient will be 19. Suppose if you are dividing 255 by 10, 255 by 10, 10 into 2, 25 is 250. Remainder is 5. Okay. What will be the quotient? Next quotient will be 25. Next dividend will be the quotient. Okay. Got the point here? See, 255 divided by 10. It is 10 into 25 is 250. Correct? 10 into 25 is 250. Quotient is 25. Remainder is 255 minus 250. That is 5 is the remainder. Following here. So quotient is 25. That quotient will become the next dividend. Because quotient is stored in A register. That will become the next dividend. Are you getting the point here? Here what is our quotient? In hexadecimal it is 19. In decimal it is 25. Agree with me. In the hexadecimal it is 19. Hexadecimal calculation. That means divide A by B means next time what it will do? It will divide 19 hex divided by 0A. Perform this operation. Do that 19 divided by 0A. Check it how much it is. 19 keep in hexadecimal mode only and perform 19 divided by 0A. Check how
2,
much it
sir.
is.
2.
2. Right? That is our quotient. Remember. Okay. Quotient will be stored in A register. A is equal to 02. A is equal to 02. Then what will be the remainder? How will you find the remainder? The quotient is 2. Okay. 19 minus 0A into 2. Right? What I told here, the dividend minus divisor into quotient. Dividend minus the divisor into quotient. That will give the remainder. That is 19 minus how much we have to perform? 0A into 2. 19 minus 0A into 2. How much you will get?
5, sir.
5, sir.
0, 5.
5 is the remainder. Very good. 5 is the remainder. It is 5. Okay, 0, 5 or 5. Both are same, right? Now, remainder we got. Okay. What was the first remainder? First remainder we have already stored in R7. 5. The second remainder is also 5. Second remainder is also 5. Correct? Now, this remainder, this remainder we'll store it in the next register according what they have mentioned in the program statement. Move R6 comma B, R6 comma B. That is R6 is equal to value in B, that is 5. Means remainder whatever you are getting, you have to go on storing them. First remainder whatever you are getting, that will be your least significant digit of the converted decimal number. You are converting hexadecimal number to decimal number. right? The first remainder what you are getting, that is the least significant digit of the decimal number equivalent of the given hexadecimal number. Then next remainder what you are getting, that is the middle digit. Then the last remainder what you are getting, that will be your most significant digit of the given hexadecimal number. Okay. Now move R6 comma B, the middle remainder, the second remainder I have stored in R6. Then what I will do is, if you want, desire, if you want, then you can perform again the quotient, that is now quotient is 2. This you can divide by the A or 10, right? And you can find the quotient and remainder, or what you can do is whatever is the quotient, that will be itself the remainder. Suppose you are dividing 2 by 10, right? 2 by 10, so 10 zeros are 0, 2 will be the remainder, correct? Am I right? If you are dividing 2 divided by 10, 10 zeros are 0, 2 minus 0 is 2, remainder will remain 2 only. That is the quotient, that is the dividend itself. It is the dividend itself. So what I will do here is, instead of performing one more division operation, what I will do, whatever is the value in A, that itself, that is the dividend value, that itself is my most significant digit. Move R5 comma move R5 comma A. Move R5 comma A. That is, this is the most significant digit. R5 is equal to A, that is equal to 2. This is our most significant digit. MSD, most significant digit. Now, which is our in between middle digit? This is our middle digit. Okay, yeah, I will write it here, MD, middle digit, and this is our least significant digit, R7 comma B. This is our least significant digit, LST. Now, what is the final answer then? Most significant digit is 2. Most significant digit is 2. Middle digit is 5. Middle digit is 5. Then least significant digit is 5. This is the decimal number. This is in decimal D. Okay, decimal number of the given hexadecimal number of the given hexadecimal number. What was the hexadecimal number given to us? FF hex. FF hex. For this FF hex, the decimal equivalent is 255D. Clear here? This is how we are calculating, converting the given hexadecimal number to decimal number. Okay. This is the conversion. So if the program statement is given like this, you have to write the logic. Think about the logic first, and accordingly you have to sequence the instructions. You have to write the instructions in the sequence, so that the first we should get the least significant digit, then the middle digit, and the last one is the most significant digit. Clear here? Is the logic clear here, students? Logic is important. Then if you have understood the logic perfectly, you will be able to write the program. Logic is clear here? Logic is clear to everyone? Abhinandan, logic is clear? Abhinandan? Shirati? Bhagyashri, logic is clear? Bhagyashri? Gat Pratmesh Shivaji? Gat Pratmesh Shivaji? Jyoti? Jyoti? Mantesh?
Yes, sir.
Clear? Logic is
Understood.
clear?
Yes, sir. Clear.
Okay, fine. What about the next part of the program? How will you do that? What they asked in the next part of the program is simple. It's same as the first part. Analyze the program assuming that P1 has a value of FDH for the data. You take it as homework. Analyze the program assuming that P1 has a value of FDH for the data. If P1 has the value FDH, then you have to analyze. Just you have to analyze. Need not write a program for that. Just you have to analyze for that. Okay. Sorry. If P1 is having value FDH, then you have to analyze the program. That is, what will be the first remainder, what will be the quotient, what will be the second remainder, middle value, what will be its quotient, and what will be the final remainder. Okay, just find out that. That will be your analyzing the program. Okay, need not write a program again. Just you have to write the values, that's all. Okay, on one side you write first FD divided by 0A, what is the quotient, what is the remainder. Okay, FD divided by 0A, then you will get the quotient as 19. Next division will be 19 divided by 0A, what is the quotient, what is the remainder, that will give the middle digit. Remainder will give the middle digit for the second division, and the last one will be the whatever is the dividend, that will be itself your remainder. So that is the least significant digit, okay. So do that, and tomorrow tell me that what quotient you are getting and what remainder you are getting for the different division operations. Fine. Is it understood here, today's programs? Is it clear to everyone? Mole Prem, is it understood? Mole Prem?
Yes, sir. It's understood.
Okay. Fine. Nagesh? Nagesh? Pooja? Understood? Okay. Okay, fine. Sridhar Solkanor? Understood? Srushti? Srushti?
Yes, sir. Yes, sir. Understood, sir.
Clear with the today's programs?
Yes, sir.
Okay. Supriya? Supriya?
Yes, sir. Understood.
Okay.
Yes, sir.
Fine, fine. Vandana? Vandana? Mahesh? Dudmani? Taik Mohammed? Taik Mohammed?
Yes, sir. Understood.
Okay. Abhishek Palekar? Abhishek? Bhaurav? Bhaurav? Shodhan? Shodhan? Devanawar Anil Kumar Shekappa? Devanawar Anil Kumar Shekappa? Sridhar Badiger, is it clear? Badiger? Sridhar? Vaishnavi? Vaishnavi? Understood? Okay. We'll wind up the session here. In the next class, we'll be starting with the next module. Okay. We'll wind up the second module and we'll start with the next module in the next class. Right. Thank you.